The challenges we face are immense, but companies are proving that green business practice can make money. Now, one sector that possibly has the steepest hill to climb is the chemical industry. The chemical industry is one of the world's largest. Its products and technologies are used in almost every area of the world economy. BASF, the world's leading chemical company, is responding to the challenge of climate protection. The company constantly reduces greenhouse gas emissions, in absolute terms and per tonne of sold products. Compared to 2002, the organisation has set a target to reduce its specific greenhouse gas emissions by 25% and increase the energy efficiency of its production by 25% by 2020.
One of our 4 strategic guidelines is ensure sustainable development. So, resource efficiency and climate change are strategic targets of BASF. Executing these targets and this strategy, we clearly need to set standards. And we do this operationally via running our plants, but also through our products. And here BASF, as the chemical company, has to take up leadership.
BASF's climate protection activities are focusing on 2 areas: its internal operations and innovative product development. The BASF headquarters here in Ludwigshafen, Germany, is the world's largest integrated chemical complex, with a total site area of 10 square kilometres, over 32,000 employees and more than 200 production plants. One of the innovative solutions to directly decompose greenhouse gas emissions is a high-tech industrial N2O laughing gas catalyst.
Nitrous oxide is indeed a very, very high potential greenhouse gas. The factor compared to CO2 is 310. That means if you would reduce 1 ton of nitrous oxide with this catalyst, we have the same benefit as if we would reduce 310 tons of CO2. Our catalyst is decomposing laughing gas into harmless nitrogen and oxygen.
The catalyst is used in the company's internal plants and throughout the world. This achieves global savings of 40 million tonnes of CO2 equivalents annually. Worldwide, BASF operates 6 sites with a unique Verbund strategy. In these, production plants are intelligently linked to save resources and energy. This helps to save 3.7 million metric tonnes of CO2 equivalents each year.
The high energy efficiency of our Verbund sites is BASF's most effective contribution in reducing greenhouse gas emissions and thus for climate protection.
The combination of gas and steam turbines operating on the cogeneration principle provides an overall efficiency and energy utilisation of almost 90%, making it the frontrunner in industrial energy conversion. With this technology, BASF generates 3/4 of its global power demand, saving a further 2.2 million tonnes of CO2 equivalents annually. BASF has established a method called eco-efficiency analysis. This helped to calculate the corporate carbon footprint of BASF and shows the corporate emissions and emission savings of products during their complete life cycle.
BASF's corporate carbon footprint is, on the one hand side, BASF's own emissions in terms of greenhouse gases, but on the other hand side, it comprises the savings that can be achieved through BASF's products. And these savings were generally calculated via eco-efficiency analysis.
The results of 2008 show that the use of BASF products saves more than 3 times as much CO2 as is released by all of their production and disposal. This illustrates a ratio of 3:1 to the benefit of the climate. Modern insulating materials are one key to energy-efficient housing and can lower the amount of energy usage to heat and cool buildings. BASF has built a number of low-energy homes around the world. Here in Nottingham in the United Kingdom is one such low-energy residential home. In 2008, working in partnership with the University of Nottingham and its customers, BASF built this low-energy home.
The BASF House project was to show that an energy-efficient and affordable house could be built. The project was a true cooperation between the University of Nottingham's passive house knowledge and BASF's innovative products.
The low-energy house uses a number of innovative materials developed by BASF. One of these is MicroNal PCM, a phase change material that's used indoors for smart temperature management. Specially formed wax capsules are designed to absorb heat when a room reaches its comfort temperature. This stored heat is then released at night when the air temperature cools. The low-energy house also features insulated concrete formwork made from a specially designed material called Neopore. By adding graphite to expandable polystyrene foam, BASF has improved its insulating capacity. The use of BASF materials quickly creates a highly insulated and energy-efficient building envelope. The impact of the technology's materials and designs are all being carefully monitored by Nina Homazabal Pobletti, an architecture PhD student who lives and works in the low-energy house. Nina uses monitoring systems that track temperature, relative humidity, light, solar intake, and ventilation data.
I've been living in the house for the last 15 months, and it's been a great experience. I've been observing and studying the house during this time, and one of the most striking things is the no use of heating, actually. We used the heating system mostly in February, and was the only month that we needed. And the house performed very well with the sun space and with the insulation.
BASF's answer to the challenge of climate change is to work on increasing energy efficiency, conserving resources and reducing emissions, and to ensure that its products are enabling customers to protect the climate. Well, that's it for today's episode. My name is Flemmick Webb. Thank you for watching.